You know how we're always talking about these amazing large language models? They can write code, generate images, but there's that one big
The
catch.
forgetting part.
Exactly. They
Hmm.
just seem to forget everything once you close the window, like a, well, super smart goldfish.
Right.
So we've been thinking, wouldn't it be great if AI could actually remember things, have a kind of persistent memory?
Well, that's precisely the problem OpenMemory MCP is setting out to solve. We've been looking at this really great article from the DEV community, originally on mem0.ai, that breaks it down.
Okay.
And the idea is basically a private, local, first memory system for AI. So you get that context-aware AI across different apps, but crucially, your data stays with you.
Okay, OpenMemory MCP. Let's dig into that. In simple terms, what is it? And, why should you, our listener, care about this, whether you're a dev or just interested in AI?
Right. So think about your AI tools now. Their memory of past chats, your projects, it's
Yeah.
pretty much gone session to session.
Yeah, vanishes.
OpenMemory MCP wants to fix that.
Huh?
It provides this dedicated memory layer. It's private, and it's designed for clients that use the standard memory control protocol, MCP.
Okay.
Basically, it's the plumbing that lets these AI apps store, manage, and, actually use their memories
Huh.
across sessions, maybe even different apps. And the key is it stays local on your machine.
So it's like giving the AI a proper long-term memory boost.
Yeah.
A place that remembers not just facts, but our context, too.
Exactly. And getting slightly more technical, the article talks about it being vector-backed for clients using that MCP standard.
Vector back.
Now, this vector-backed bit is important. It means it's not just storing text. It uses vector embeddings to understand the meaning behind the text.
Ah, vector embeddings.
Right.
So when AI searches its memory, it's not just looking for, specific words.
Precisely.
It gets the concept. So it can pull up way more relevant stuff than just a simple keyword match.
That's the power. And the core features of OpenMemory really show this. It stores and recalls basically any text chunk. Those are the memories, does it across sessions. And crucially, it uses QDRANT.
QDRANT.
Yeah, it's a vector database designed exactly for this kind of work with embedding. So that enables the relevant search we're talking about, semantic search.
Makes sense. Now, privacy. That's a huge concern for everyone with AI right now.
Yeah.
How does OpenMemory handle that side of things?
That's absolutely central to its design. It's built to run entirely locally on your own setup.
Okay.
The article mentions using Docker, Postgres, QDRANT standard tools, but running on your hardware. So no data leaves your system, period. You're in control.
That is a big deal. That local first approach.
It really is.
The article also mentioned granular access controls.
Yeah.
What does that mean? How much control do I actually have?
You get really fine-grained control. You can pause an app's access to memory or just revoke it entirely. And you can do that for specific memories, too, not just the whole app. Plus, for transparency, every read, every write, it's logged, an audit trail.
So you can see exactly what's happening.
Yep. You know exactly how the AI is using its memory.
And there's a dashboard to see all this.
Yes, a full dashboard, built with Next.js and Redux, so it's pretty slick and responsive. It gives you that visual overview, which apps are connected, what memories are being accessed, any changes, your command center, basically.
Right. Okay, so we get the what and the why, privacy, smarter AI, local control. How does it actually work, though? What's the basic process?
Well, the article stresses the setup is pretty straightforward. Getting the main parts running the API, QDRANT, Postgres. It's often just one command using Docker Compose.
One command. Seriously, that sounds easy.
Yeah, they've tried to make it simple. Docker Compose just orchestrates all those different services for you.
Okay.
So once it's running, the API hosts the MCP server. It uses a library called mem0 under the hood for the memory stuff.
MEMS. Got it.
And the communication between your AI apps and this server, that happens using the standard MCP protocol, but over something called server send events, or SSE.
SSE, yeah.
Yeah, think of SSE as like a continuous one-way data stream from the server to the client. It's sufficient for this kind of real-time stuff.
So the AI app opens this stream to OpenMemory, and they just talk.
Pretty much.
Yeah.
The LLM client connects to specific addresses, the endpoints, on OpenMemory, usually something like MCP.
Right.
And through that live connection, the client uses methods like add memories to store new stuff, search memory to look things up semantically, or list memories to just see what's there.
So it's a constant conversation happening through that connection. The AI learns, recalls
Yeah,
seamlessly.
exactly. And OpenMemory handles the back-end heavy lifting. Creating the vector embeddings for search, keeping the audit logs, enforcing your access rules, all that happens automatically. If you want to see it in action, the article links to a demo and more info at mem0.ai OpenMemory-MCP.
Good to know. Now, for those of us who like to tinker, the article actually gives a step-by-step guide to setting it up. Let's walk through that.
Sure. So the guide splits the project into two main folders. AP for the backend, the MCP server logic, and U for the front-end dashboard you see.
Makes sense. Back-end engine, front-end controls. What do we need installed first? Prerequisites.
Okay, you'll need a few standard dev tools. Docker and Docker Compose are key for running the containerized services.
Right, Docker.
Then Python version 3.9 or newer. Node.js for the front-end part. You'll need an OpenAI API key for some features, like the auto-categorization.
Okay.
And GNU Make, which just simplifies running build commands. Oh, and the article stresses making sure Docker Desktop is actually running.
Got it. Tools are ready. First step.
First, grab the code, clone the repository from GitHub using the git clone command they provide.
Standard stuff.
Then you need to set your OpenAI API key. The article shows using the export command, like export OpenAI key, your key here. Just remember that usually only lasts for your current terminal session.
I need to make that more permanent later, maybe. Okay, code cloned, key set temporarily. How do we fire up the backend?
This is where make comes in handy. Three main commands. Make and vcopies a template environment file. Builds the Docker images.
Okay.
And make up, well, that starts everything. Postgres, QDrant, the main API server.
Makeup. Nice and simple.
Yeah. And typically you'd put your actual API key in a file called .env.local for persistence. Once makeup finishes, the API should be live at localhost 0.800. You can check Docker Desktop to see if the container is running.
Good visual check. The article mentioned other make commands too. Anything particularly useful?
Definitely. Make migrate handles database schema changes. Super important. Make logs shows you the live output from the services, essential for debugging.
Oh yeah, logs are key.
Make shell drops you into the API containers command line. Make test runs the backend tests. And make down stops everything cleanly. They're all pretty useful for managing your local setup.
Okay, backend sorted. How about the dashboard?
Yeah.
Getting that running.
Just as easy. Go to the project's root folder in your terminal and run make we.
Bakery. Okay.
That command installs the front-end dependencies using PnPM, then starts the next.js development server. Once that's done, you just open your browser to localhost tot300, and there's your dashboard.
And this is where we hook up our AI clients. Start seeing the memory in action.
Exactly. The article explains how MCP clients connect via that SSE channel. The dashboard gives you a one-liner command to help install the necessary server component into clients like Cursor, Claude, Windsurf, Klein.
Oh, handy.
It gives an example command for Cursor, though notes it's just a demo placeholder for now. You'd usually verify the connection in the client settings too.
Makes sense. So, client connected. How do we, use the memory, store something?
Well, the article uses Cursor as an example. You might prompt it, say, remember my preferred programming language is Python. That interaction triggers the client's add memories function.
Yeah.
That info gets sent to OpenMemory. Then, if you pop over to the dashboard, go to the Memories tab, you should see that new entry. And interestingly, it mentions these memories can get auto-categorized using GPT-4o.
Auto-categorized. That's pretty smart.
Yeah.
Helps keep things organized.
Yes, sir.
What were those 4 standard MCP actions again?
Right. The 4 main ones are add memories to store stuff, search memory for that semantic lookup based on meaning, list memories to just get everything for a user, and delete memories for a clean slate.
Got it. Add, search, list, delete.
Yep. And the responses all stream back over that SSE connection. The dashboard shows you active connections and logs the details of every access.
Okay, the dashboard sounds like the real control center. What can we actually do in there? What are the main features?
It's mainly organized around 3 routes, or pages. The main overview page, a detailed memory management page, memories, and a page listing your connected apps.
Okay, so connecting a new client, how does the dashboard help there?
On the main page, it gives you your unique SSE endpoint address that clients need. And it has that one-liner install command we talked about.
Right.
It even has tabs for different clients. Claude, Cursor, Clang with specific instructions for each. Makes it easier to get started depending on what tool you're using. You can toggle between the raw link and the client instructions.
Nice. And once clients are connected and adding memories, what kind of overview do we get?
The main page shows key stats. Total memory stored, total apps connected. It even shows icons for up to 4 apps.
Quick glance info.
Yeah. And there's a live search bar right there, too. You can just type in search across the content of all your memories instantly. The article points to the specific code file stats.tsx if you want to see how that data is fetched.
That live search sounds super useful as memory grows. What else can we do to manage the memories themselves?
There's a refresh button, obviously, to pull the latest data, and a create memory button that lets you manually add a memory entry through a little dialog box. Could be handy for adding initial context or notes.
Manually adding. Okay.
Yeah.
What about sorting or filtering when you have, like, hundreds of memories?
There's a whole filter panel for that. You can filter by the app that created the memory by its category, remember the auto-categorization, or show hide archived item.
Archiving. Good.
You can also sort the list by different columns. The memory text itself, the app name when it was created, and there's a clear all filters button too.
So pretty standard, but essential, filtering and sorting.
Yeah.
What about actions on individual memories?
Yeah, when you click on one, you get options. Archive it, like you said, if it's old but you might need it later. Pause it so the AI can't access it temporarily. Resume it later. Or just delete it permanently.
Pause, resume, delete. Okay.
You can also see the specific access logs just for that memory, who accessed it when, and see related memories. Oh, and you can select multiple memories and do bulk actions, like archive or delete a bunch at once.
Bulk actions, nice, saves time. It really sounds like a comprehensive control panel. The article gave a quick peek behind the UI too, didn't it? Mentioned some code components.
It did, yeah. Highlighted things like memoryfilters.tsx, which handles the search, filters, and bulk actions. Memorysection.tsx manages loading and displaying the memories, pagination, all that. And memorytable.tsx actually renders the table itself with the per-memory actions.
Oh, okay.
And for fetching data and managing state, it uses custom React hooks like use stats.ts, use memoriesapi.ts, use appasapi.ts, use filtersapi.ts. These work with Redux Toolkit to keep the interface snappy and up-to-date.
Right, standard modern front-end stack. Okay, let's switch gears slightly. Security, hugely important here. What's OpenMemory MCP doing on that front?
Well, the whole privacy-first, local-first design is the foundation. Your data stays local in those Docker containers.
We'll cover that, yeah.
For handling data safely, the backend uses SQL Alchemy, which helps prevent things like SQL injection attacks when talking to the database. And every memory interaction is logged. Adds, searches, reads, it's all tracked.
The audit trail.
Exactly. Now, the article notes that this version doesn't have built-in user authentication yet, but the API endpoints are designed for it. They require a user ID, so you can easily put it behind an external auth system.
Okay, so it's ready for proper authentication.
Right. It also mentions the CORS policy is wide open by default for local dev use, but you'd absolutely need to lock that down in a production setting.
Standard security practice.
Okay.
So the foundation's there. What about controlling which apps access which memories? That fine-grained control.
Yeah, that's handled via a specific database table, access controls, and a function in the backend, check memory access permissions.
Okay.
This function looks at the memory state, is it active, paused, the app's status, is it active, and any rules you've set in that table. So you can say, pause all access for app X, or archive this specific memory, or filter things by category or user. And importantly, paused memories or memories belonging to inactive apps just don't show up in searches.
So really granular control. That seems powerful. Okay, let's zoom out again. The overall technical architecture. How do all these pieces fit together?
You've got the backend built with FastAPI and FastMCP. That's the brain. It offers two interfaces, a regular REST API for management and that MCT interface using server-sent events for the AI agent communication, adding, searching, listing memories.
Right, the two interfaces.
That backend talks to two main data stores. Postgres for the structured relational data.
Like users, apps, logs, categories, access rules.
Exactly. And Qdrant for the vector embeddings and semantic search.
Got it. Two databases, different jobs.
Precisely. Qdrant handles the what does this mean search. Postgres handles the who, what, when, where metadata. The backend uses Squalchemy to talk to Postgres and Alembic to manage database schema changes. Default is SQLite, but easy to switch to Postgres via the database URL.
Makes sense. And the dashboard.
That's the Next.js front end. Uses Redux for state management, hooks, and Redux Toolkit to keep things clean, Axios for API calls, and libraries like Recharts for charts and React Hook Form for forms. Okay.
And the whole thing is packaged up using Docker Compose, docker-compose.aml, with makefile shortcuts for development and PyTest for backend testing.
So, summing up the architecture. Self-hosted memory, data split between relational and vector stores, security via ACLs, semantic search via Qdrant, all managed via the dashboard. Seems solid.
Yeah, it's a well-thought-out approach.
Now, the really exciting part, practical uses. The article gave some great examples.
Yeah, these really show the potential. First up, a multi-agent research assistant.
Ooh, interesting.
Imagine you have several AI agents, each specializing in a different research topic. They all store their findings in open memory using add memories. Then, a master agent can use search memory to query across all their memories, synthesizing information.
Wow.
The auto-categorization helps organize it. ACLs control access. The article even links to a repo for building something like this and suggests maybe using LangGraph to visualize the knowledge flow.
That sounds incredibly useful for complex projects. What else?
Another one is an intelligent meeting assistant with persistent memory. Okay, I think many of us could use that.
Right. An AI that takes notes, IDs, action items, summarizes, but then remembers it all for the next meeting. Before your follow-up call, it uses search memory to pull relevant context and action items from past meetings.
That would save so much time recapping.
Totally. It uses add memories after each meeting. The dashboard shows related memories and logs. The article suggests integrating with Google Drive, Notion, GitHub to link action items too.
Huge productivity potential there. One more example.
A third one is an agentic coding assistant that learns with you.
How so?
It remembers your coding style, solutions to errors you fixed before, project-specific nuances. It uses add memories to store these patterns and fixes. Then, when you hit a similar problem, search memory brings back the old solution.
Like your own personal coding knowledge base.
Exactly. You can check the dashboard, pause old stuff. It even floats the idea of connecting it to CodeMod tools for automatic refactoring based on learned preferences.
Very cool. So, across these different scenarios, research, meetings, coding, the common thread is giving AI that long-term semantic memory.
Exactly. That's the core benefit. Semantic recall, relational tracking, and a dashboard for control, all locally stored under your control.
It really tackles that goldfish memory problem head-on.
It provides that persistent layer that current stateless LLMs are missing.
This has been a really fascinating deep dive into OpenMemory MCP. It genuinely feels like a big step forward.
I agree. Providing this private, local, controllable memory, it really opens up possibilities for much more personalized and genuinely useful AI applications.
So for you, our listener, as you think about all this, consider how different your interaction with technology could be if your AI tools had a reliable, persistent memory, a memory that you control. What kinds of things could you build? Or how could you use tools differently if they could learn and remember over time securely on your own terms? Definitely check out the resources from the article if you're curious.
Yeah, start thinking about the use cases.
It's definitely an exciting time in AI development, and giving AI a proper memory seems like a really fundamental part of its evolution. Thanks for joining us for this deep dive.